Your agent cost $8,000 a month. Now, how do you reduce without hurting the quality? Now, if you said, I'm going to use a cheaper model, you just failed in the interview. This is real Agentic AI interview questions. We're going to look into the cost optimization and guardrails. So let's go. Welcome back to this interview series, guys. And if you missed the earlier part, you can check out the links, and we have also mentioned in the comments as well. So go ahead and check that information. Now, I'll be going through the real interview questions that the experienced professionals get asked whenever you're interviewing for the agentic AI role at the production companies. Now, this is not the surface level stuff. The questions that separate people who have actually built demos versus people who have shipped the system. So today, I'll be covering two critical production concepts, that is cost optimization strategy and the guardrail placement decision. Now, these questions are the one that's going to expose whether you understood the production constraint or just theory. I've sat through more than 40 plus interviews in the last quarter, and these two questions trip up 70% of the candidates, not because they are hard, because the obvious answer is wrong. So let's break that down. So the key question, that is the question number one right here, is your agent system is costing $8,000 per month. Leadership wants you to cut it in half without degrading the quality. Now, walk me through your approach. Now, this is a classic production engineering question. Now, let me show you what most of the candidates say and why it's incomplete and what you should actually say. See, the most incomplete answer or the common answer that I would say is I would switch to a cheaper model. Now, this is what I've seen more than 60% candidates say at first. And it's not wrong, it's just incomplete. Now, here is why this answer will get you rejected. It shows you reach for the model before you understand the problem. That's actually backwards. You optimize the system, then the model if required. Second, it ignores that the model cost is generally 20 to 40% of the total cost. If your model is, let's say, $2,000 a month, and let's say your embeddings are $3,000 a month, then even if you switch to the model, or even if you switch the model, whatever that you have saved, it's nothing meaningful. And third, the another scenario over here is it shows that you don't know how to analyze the cost structure. But when you talk about the production engineers, they dig into logs before they make any changes. Now, let me show you the answer that gets you hired. Now, here's what I would generally say in the interviews. First, I would analyze the cost breakdown, and I need to know where exactly this $8,000 is going before I can optimize it. Then I generally enumerate what I would check. So I'm going to check the embedding cost, like how many embeddings per month? What is the average input size? I'll also check about, are we embedding the redundant data? So this is one of the real example where a client was actually embedding the entire PDFs, including the headers, footers, and page number. So what was happening was, because of this, 40% of tokens were actually metadata. So one of the fix could be here is we'll strip the metadata before embedding, and that would actually help us in saving of $1,200 per month. Again, depending on the use case, in some scenarios, like in medical and healthcare, these headers would also make sense. It's up to us as how we approach it, like not when directly removing it, but considering it in other parts of the pipeline. Then the second step is LLM inference cost. I'm going to ask as input token distribution. That means, are we sending too much context? I'm going to check the output token distribution. That means are the responses are longer than necessary? And are we using the appropriate model for each task? Like one of the example that I would give you over here is a client was actually using the GPT-5 latest model for a simple classification task. The fix is simple. For simpler tasks, use a cheaper and a simpler model. Maybe GPT 3.5 available, now it is 4.1 nano or Haiku. So that would actually bring down the savings, and this will be easily savings up to $1,000 a month at least. Then the third would be is the vector database cost. So I'm going to check how much data are we going to be storing? What is the retrieval pattern? Are we over indexing? So one of the example that I gave right here over here as well as a client was actually storing 10 versions of every document. One easy fix can be is keep only the latest version or keep the old ones. Now that would result in the savings of at least $400 a month. Then the next thing that we can implement right here is maybe caching and deduplication. So this is where I've seen most of the people misses it. I'm going to check, are we doing the caching of the LLM response? Are we deduplicating the similar queries? Are we reproducing the identical inputs? So these are the things that I would check. And one of the example that I give right here, especially this is worthwhile to mention over here is this. In one of the customer support bot, we have observed that there was a re-embedding that was happening. Like, how do I reset my password? Now, this thing was performing the re-embedding 200 times per day. Now, what we did was we just implemented the semantic caching with 0.95 similarity threshold, and this itself resulted in savings close to $600 per month. So already with all these approaches that I've mentioned, we are at $3,000 per month in savings by making zero changes in the model. So once that is done, then we'll walk them through these specific optimization strategies. Like the first strategy that I would mention over here is, so here, uh, like when we talk about the strategy number one, maybe I'll start with input filtering and classification. So before we embed or process anything, okay, so I'm going to ask, do we need to process this? A real example, if I want to give right here, is a client was actually embedding hi, thanks, okay, like a general questions. And these don't require the RAG retrieval. And these even don't require the agent reasoning. So what is the fix that we can do? We have to fix by classifying the inputs first. Let's say if I have greeting, these are the canned messages or canned response. There is no LLM call. And for simple question, I would direct, I would perform the direct lookup and there won't be requirement of the RAG. If there is a complex query, then we'll have a full agent pipeline. Now, this itself will result in savings close to $800 per month on savings on unnecessary embeddings and LLM call. The second strategy could be is the context window. You might be sending too much context. So I'm going to check, are we sending the entire conversation history, or are we sending all the retrieved documents, or is there a scenario where we are including the unwanted metadata? So in one of the real example that I want to quote right here is an agent was sending 10 RAG results and analysis showed 3 contained the answer, which is close to 95% of the time. So what we need to do over here is instead of getting top k as 10, we just need top k is equal to 3. That itself will help us in 40% reduction on the input tokens. And third strategy that we can have right here is response length constraint. So over here, maybe like there can be scenario where that lengthy responses might not be required by simply limiting the number of tokens. We can set the maximum tokens appropriately for each task type. Like maybe for classification, 10 tokens, short answer, 100 tokens, explanation, 300 tokens, full response, maybe 500 tokens. So that itself will help us in saving close to $500 to $800 per month. Now, again, this depends on the volume. And the fourth strategy that we would have over here is, let's say if we are processing the documents, it will check for batching. So in one of the scenario, we have observed that a client was embedding one chunk at a time. And in the backend, the embedding API supports batching. So if they implement batching, let's say by batching 100 chunks per API call, that would actually result in 30% reduction in API overhead, which would easily be $300 per month. Now, only after exhausting all these architectural optimization, then we would consider the model changes. Like the way that we would approach right here, my recommendation over here is first we'll have to identify the task complexity, because not all your task requires your, let's say, GPT-4 or GPT-5. We'll categorize. I would prefer to categorize maybe for tier one for simple classification. Maybe I'll route it for haiku or old versions of GPT or nano versions of GPT. For tier two, then we'll have RAG with straightforward questions. Maybe it could be Sonnet or GPT. And for tier three for complex reasoning, then I could use for maybe Opus or maybe the latest version of GPT. Then I'm going to measure what percentage of queries of each tier. What is the cost difference? Like to give you an example, close to 60% of queries were actually tier one in one of the use case. And they were actually using the GPT latest model at that time, that is GPT-4, which was costing them $3,000 a month. So we just had to switch the tier one to the older version, maybe 3.5 at that time. That actually came down to $150 a month. And the saving was close to $2,850 per month. Then we'll test the quality with the help of A/B testing. Because this is critical, because we should never switch the models without measuring the quality. We're going to run the parallel 10% traffic to the new model. We'll track the answer accuracy, user satisfaction, task completion, and we'll compare it to the baseline. If quality drops more than 5%, then we're never going to switch it. The step three is the hybrid approach, where we'll use the GPT 3.5 for classification and routing, and maybe Sonnet for most queries, and GPT-4 only for the complex synthesis task. Now that gives you 90% of quality at 40% of cost. So if I want to give you the summarization of the cost optimization that we are talking about, so first thing that I will do over here is I'll perform the analysis. I will analyze first. Second is we'll have to optimize the architecture. Now, once we optimize this architecture, then only we will proceed with model changes. In my experience, you can actually cut 40 to 70% of the cost through architecture, because that's where your most costs are. If you just deep dive into your task that you're working, it will be easily visible for you. And that is one of the answer that will get you hired. Okay. Now, moving on, let's take a look into the question number two. That is, where do you place the guardrails in your agent system? Walk me through your decision framework. Now, this question will actually test you whether you understand the latency versus safety trade-off. And most candidates get this wrong. The common answer that I've seen people saying is, I'm going to add the guardrails at the output to check the response before I give the output to the end user. Now, this is what I've seen 70% of the candidates say. It's not wrong, but it's incomplete and shows the fundamental misunderstanding. So first, if you have the output only guardrail, you will be wasting the compute. If the agent generates a toxic response, you've already paid for this token. It's a cost that has been incurred to you already. You catch it at the end, you have wasted the API call money. Second, it doesn't prevent the agent from entering the bad state. If the agent, if the user asks something which is dangerous, and if your agent starts reasoning about it, even if you block the output, you have exposed the system to the risk. And third, it ignores the latency impact. See, if you add 200 milliseconds of guardrail checking at the output level, every query gets 200 milliseconds slower. And for a chatbot, that's actually noticeable. So the overall answer would require thinking about guardrails as a multi-layer system, not at the output itself. So let me show you right now. See, this is the framework that I would walk through in the interview. The layer one is the input guardrail. We call it as a pre-processing. This is where you catch the problem before spending money. I'm going to check for prompt injection attempts, toxic or harmful input, jailbreak pattern, PI in user queries. These are the things that I would check at the input level. Like we'll have a regular expression based pattern for common injection, LLM based classifier for harmful content, PI detection for detection of the social security numbers, credit card numbers, and so on. And this would usually cost $0.0001 per query. It's a cheap classifier, and the latency is very minimal, but the huge upside. So latency is just 50 to 100 milliseconds. It prevents 90% of bad queries from reaching the agent itself. On the layer two, we'll have a tool level guardrail. Before the agent calls a tool or verify the parameter, I'm going to check, are the tools of the arguments valid? Does the user have the necessary permission to call the tool? And is the scope reasonable? To give you a real example, we had a tool for database query, and Guardrail clearly mentioned that you have to block, delete, and drop commands. And we also have a guardrail which mentioned that limit to select with where clause. And we also had a guardrail where we mentioned that the maximum 1000 rows returned. Now, by mentioning these three guardrails, we are actually preventing the agent from causing damage, even if it hallucinates. Now, when it comes to the cost, it's negligible. It's basically the parameter validation and latency at the max 10 to 20 milliseconds. But the benefit is it's going to prevent the catastrophic tool misuse. That's a key thing that you have to monitor for when you're building the agent for production. And on the layer three, okay, we actually have the reasoning guardrail. I'm going to mention right here. It's a reasoning guardrail. So this is generally done during the execution. Let's say when your agent is reasoning, we'll monitor for dangerous pattern. I check, let's say, is the agent is stuck in a loop? Is it making too many tool calls? Or is it accessing the sensitive resources? One of the real example that I can share right here is the agent tried to call a price check 47 times in a single query. Now we had a guardrail that max 5 tool calls per task. And because of this, we were able to stop the execution and return the error. And if you consider the cost, it's negligible. It's just a simple counter logic, and latency is 0 milliseconds. It happens during the execution. And the benefit is this prevents the runaway cost and timeout. And finally, then we'll have the layer four, which is the output guardrail, which most of them are aware of. So here, I'm going to check whether my output contain PI data. Is it toxic or is it harmful? Does it leak the system prompt? Is it factually grounded? So this would be your last line of defense. And this might cost generally $0.002 per query. It's slightly more expensive compared to the classifier. And latency is around 100 to 150 milliseconds, especially on the output guardrail. But it catches anything that might have slipped through. Okay. So this is how you would answer about the guardrail in a clear manner. Now, at the end, this is what the interviewers want to hear in the interview. So the key thing over here is you're going to optimize the guardrail placement based on your constraint. Let's say if your latency is critical, let's say if it is your real-time chat, then you need to have a heavy input guardrail so that you can catch early, then light output guardrail, and async monitoring for violation. If safety is critical, especially in healthcare and finance, you should have a comprehensive input guardrail, two-level guardrail for every action, comprehensive output guardrail, and human in the loop for high-risk transaction or high-risk output. So if the cost is critical, let's say if you're dealing with a business which is high volume and low margin business, then cheap input classifiers would really work over here. You can have a rule-based tool guardrail and selective output checking only for the high-risk queries. Now, whenever you're answering in the interview, so my recommendation is mention with specific numbers so that whatever you're mentioning, it makes sense for the interviewer. You can start by saying as for our use case, that is having, let's say 10,000 queries per day, I would allocate 100 milliseconds for input guardrail. This can catch 95% of issues and 20 milliseconds for tour guardrail, which will prevent the misuse, and 50 milliseconds for output guardrail for the final validation, and total 170 milliseconds for my guardrail overhead. Now, this gives us the overall comprehensive protection with acceptable latency. Now, let me give you a real example. There's one of the client that we worked with, that's the financial advisory client. It's basically the chatbot. Okay, that's the core chatbot. So the initial approach that we did was we implemented the output only guardrail. So because of that, we had the latency of 200 milliseconds per query. The problem was like this was able to catch around 90% of the issues. So the problem was the 10% slipped through and wasted compute on bad queries. So what we did was we implemented the multi-layer approach. The input, which had actually blocked the injections and harmful queries. So it was 50 milliseconds. Tool, which verified all the financial data access, 20 milliseconds. For output, we implemented a light validation, which is just 30 milliseconds, and total latency came to just 100 milliseconds overhead. And this had actually caught 99% of issues. It's a crazy improvement from what we had earlier. And the best part was we were able to reduce the wasted compute by 15%, where we were able to achieve same safety, lower latency, and lower cost. And that's called as the production thinking, guys. So if you notice the pattern in both the answers, the key takeaway for you is, okay, you have to analyze before optimizing. Don't jump to the solution, understand the problem first. And second thing is architecture before the models. System design matters more than your model choice. And measure everything, latency, cost, quality, because you can't optimize when you don't measure. And four, have a trade-off analysis, and this is explicit. Like there's no perfect answer. Show that you understand the constraint. And fifth, and the very important one, ensure that you showcase the real number. Don't say that it might help, say that 40% cost reduction or 100 milliseconds latency. Now, this is what separates from the experienced professional who have shipped the product from person who have understood from the demo. The person who have seen the demo, they'll say it as, I'm going to try this approach. But an experienced person who have shipped the product, who is aiming for leading the team or being a high performing individual contributor, he or she will answer as, I would analyze X, measure Y, then optimize Z, expecting, let's say, 40% improvement based on similar systems that I've built. All right, guys. So these are the questions that expose that whether you have actually shipped the system or whether you have seen the demo. So let's assume that you are interviewing for senior agentic AI role. You need to nail these questions. If you understand these production decision, but haven't actually built a structured lag pipeline end to end, then that gap will show up immediately in your interviews. So that's exactly why I created this rack system design from data to deployment. So this program is focused on the production foundation that most engineers skip, that is architecture, orchestration, guardrails, observability, and deployment. So this is essential because before you optimize the system, you need to know how to build them correctly. So I've linked everything in the description. If it aligns, go check it out and subscribe to our channel for more such content. And I'll see you next time.